Welcome to today's presentation on functions and procedures in programming. In this session, we will explore key concepts that help in writing modular and reusable code. A function is a block of code that performs a specific task and can be reused multiple times in a program. Functions help in breaking down complex problems into smaller, manageable parts. They allow us to write more readable, maintainable, and modular code. Here's how we define and call a function. To define a function, we specify its return type, name, and the parameters it takes. For example, the function add takes two integers and returns their sum. When calling the function, we simply pass the required arguments like in add 3, 4 and get the result. In programming, we can pass arguments to the two functions in two primary ways, by value and by reference. When passing by value, a copy of the argument is made, so changes inside the function does not affect the original value. On the other hand, passing by reference allows the function to modify the original argument directly. Recursion is when a function calls itself in order to solve smaller subproblems. A recursive function has two parts, a base case which stops the recursion and the recursive case where the function calls itself. For example, a factorial function calls itself repeatedly until it reaches the base case. Recursion is important because it simplifies solving problems that have repetitive, self-similar patterns. Problems like sorting, searching, and traversing trees can often be solved more elegantly using with recursion. However, care must be taken with recursion as it can lead to performance issues like stack overflow if not managed properly. Closures are functions that remember the environment in which they were created, allowing them to access variables from their surrounding scope. High order functions, on the other hand, are functions that take other functions as arguments or return functions as results. These concepts make your code more flexible and allow for advanced programming techniques. Functions can return different types of values such as integers, floats, or even objects. Function overloading allows us to define multiple functions with the same name but different parameter types. This helps in writing cleaner code when we have similar operations for different types of inputs. Lambda functions are anonymous functions typically written in a single line of code. They allow for concise and functional programming, often used as arguments for higher order functions. In Python, for example, a lambda function can quickly perform operations without requiring a full function definition. When it comes to function scopes, there are local and global scopes. Variables defined inside a function are local, meaning they are only accessible within that function. Global variables, however, can be accessed from anywhere in the program. Understanding scope and lifetime is essential for managing variable access and preventing errors. When solving problems, we often have the choice between recursion and iteration. Recursion can be elegant and simplify the solution for certain problems, but it may lead to issues like stack overflow. Iteration, on the other hand, can be more efficient for tasks that don't naturally fit into a recursive pattern. To summarize, functions allow us to modularize and reuse code. Recursion helps us solve problems by calling functions within themselves. Higher order functions and closures make our code more flexible and concise. Lastly, understanding scopes, return types, and function overloading are essential for writing efficient and maintainable code. Thank you for your attention. Now let's open the floor to any questions or discussions on the topics we have covered today. Feel free to ask about real-world applications of functions, recursion, or any other programming concepts.